The sun is in the sky. Dee 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 dee. Hello everybody, I am Matthew, also known as the Meteor of Hope, and today we are doing something new. Wacky Science. Now, Wacky Science is where I do something fun with science. Like you put science and fun and make funnits together. That's what they do. And another thing what we do is I pick a topic and then I have no limits and do whatever I want with the resources that I have. I don't have that many resources. So, what are we doing today? Well, first day will be stars and how stars are born. Not the stars on Hollywood, not those ones. Those ones up in the beautiful sky. Actually, they're in space, but we perceive them as they are in the sky. I mean, I could just imagine a little kid like, Mommy, Mommy, there's only stars out there. They're so white. They're not white. Not all stars are white. Most of them are different colors, except for green and purple. Those are colors that are not used in stars. Anyways, so star, first of all, is born by the element of hydrogen. What happens is there's a gas cluster of hydrogen in space, and it then starts swirling around itself after a couple billion years, and it begins to create a protostar. And that is basically a baby star, and it's small. But because of that little center of gravity, it starts to swirl around itself, collect more gas, and all the excess gas that it does not want is used for the planets and other rocks. Now, when our star is created, it undergoes fusion. And a star is anything above 75 times the mass of Jupiter or bigger than that. Anything smaller than that is considered a planet. And also another thing that you can determine by a star is it undergoes fusion. And so fusion happens later in a little bit later in the star's life, where it starts to have all those hydrogens are starting to crash into each other, and because they want to, and because of that it creates helium, and helium can create other elements such as carbon or oxygen or nitrogen, argon, neon. So yeah, that's basically what happens. Now, it's also categorized into layers. And these layers are one after another, and each one of these layers then has like a different amount of elements, and I will show you also a comparison of how big stars can get. I know it's kind of random going from layers to stars, but stars are able to have these just be all these sizes. So our sun, our beautiful, beautiful sun, will be represented by this sucker ball. This sucker ball. And then our Earth is represented by this little marble here. And so you can definitely tell that our sun is way big and it's going to crush it. I mean, it can crush this thing. Crush our Earth. And over a period of time, our sun, in the palm of my hand, starts getting bigger and bigger and bigger because it's getting old. And because it is making so much elements, it needs more mass. And so that all that mass starts to increase, and the temperature starts to increase, and it becomes a gigantic red giant. And the red giant will be represented by this gigantic jumbo ball. Jumbo. And our little sun, represented by this little bead right there. It's very little. You can tell it's very little. Alright, and so what happens is our big gigantic sun, which is now a red giant, is undergoing more fusion and it can create a little bit higher elements, but it's getting old and fat. And so by these comparisons, you can definitely tell that it's going to get pretty big. During that time, it's going to actually surpass definitely surpass our orbit, and Earth will be destroyed. And also will be Jupiter. Jupiter's way out there, yes it is, but because of the size of our sun, it'll eventually get out there as well. So let's see what happens after that. Well, it starts to collapse on itself, and because it's so big and fat that it can't hold up its own mass, so it collapses on itself and becomes a planetary nebula. So yeah, it's just back to a nebula again, so it's another colorful gas cloud. And then, what happens is, unfortunately, it becomes a white dwarf, which is inside the planetary nebula, and the white dwarf is exactly the same size as our Earth, which is sad. Yes, it's very sad. Now, there's also high mass stars, or bigger stars, like Will Ferrell, for instance. No, not going there. So, anyways, a high mass star is undergoing the same exact process from the beginning as a low mass, except there's one little difference. It's bigger. Alright, so because of its bigger size, its core has a lot more density. So that means that it is definitely a lot bigger, and the core would be a lot bigger. Density equals 1, because water has a density of 1, and so a star has big enough density that it would not float, but it would have, it will float, or it won't float, it'll sink. But a high mass star would even sink further. Anyways, so that means it can undergo a lot more different kind of fusion. So it can go up to iron. I know sometimes I get a lot off track. It's me. Oh yeah. So how big would another star be to our own star? I'll show a chart later on the different sizes. And another very interesting factor about a high mass star is when it collapses on itself, it doesn't when it gets to a red supergiant, not a red giant, or it's supergiant, or if it's really big star, it can get up to a red hypergiant. And what happens after that? Well, it blows up. It's like a gigantic bomb. I mean, a star is basically a ticking time bomb. It takes like so long until the fuse just runs out after billions of years, and it blows up, and it becomes a supernova. And after the supernova, there's several things that can actually happen. It turns into a planetary nebula and becomes a white dwarf, or instead of a supernova, because of its mass, its gravity cannot hold itself up. When it collapses, it turns into a black hole, which is basically an infinite hole of death, because not even light can go through it, and nothing can actually exist inside there, so everything that goes in is basically split apart into millions and millions of particles, which is very sad. Or it could turn into a neutron star, which is where when it collapses, all the particles inside a nucleus of an atom is split apart from itself, and it becomes like the neutrons are just having a party inside the core, and so it turns into a neutron star. That's basically it. At the end of every video of these wacky science videos, I will also do fun facts. Fun fact number 1 about a star. One of the red supergiants in our own galaxy is known as Betelgeuse. It looks weird. I mean, spelling is weird. It is in the upper left-hand corner which, if I'm correct, Orion would be around there in the Pacific Northwest. It'd be around there, and it's in the upper left-hand corner of Orion. And scientists predict that it will be the next one to have a supernova. And human eyes have never seen a supernova since 154 AD. Yeah, that'd be so cool to see. I'd love to see that. It'd be kind of fun for a star to blow up. Also, because of our Earth's rotation, after a while of time, we would see stars in a different pattern. So they all look different after billions of years. So what a person saw, like the Big Dipper, let's say 100,000 years ago, which is a really long time, looks actually different from what it looks today. And 100,000 years into the future, it also looked different. So after a period of time, it would have a different, because of the rotation of the Earth and our solar system, we'd see stars in a different pattern. Well, that's about it. I don't think I forgot anything else. I hope I didn't. That'd be great. Or not great. See, I get this weird confusion. Okay, I am Matthew. And more interesting things will be coming up next. Have a good day. Goodbye.